A bus company took a tour bus on the ferry when there were 30 people on board. Says the ferry charged the bus company 180 bucks. The following week, the bus had 50 people on board, and the ferry charged them $220. Asks how much is the base rate for the empty bus. So an empty bus would be how many people? Zero. So we're looking for the cost when we have 0 people. If you have 0 as your input value or your X value, then the output or your Y value would be called our Y-intercept, right? So when they say base rate here for an empty bus, they're saying essentially, what is your Y-intercept of this equation? All right, so we want to figure that out. When we talk about a ferry, we're talking about a boat that takes people from one place to the next, right? Okay, so this bus just drives on it, and that ferry then transports them. So make sure we understand that. When we read this, okay, how much did 30 people on board cost? All right, so 30 people got paired with 180 bucks, right? So the way we write this ordered pair is that we're going to go, our X values are our people, and our Y values are our costs, right? I think if we write that or do it that way, some people do it this way, some people will write like, this is the way I do it when I work in my college algebra class. We'll just go like P for people and then dollar amount for cost. But every one of my ordered pairs, the X value is going to be an amount of people and the Y value is going to be an amount of dollars. Okay? So what's my other ordered pair that they give me here? 50 and 220. Good. Once we're able to decipher that information out of the story, now we can totally neglect the story, right? Now it's just a problem where you've got these 2 points on a line. They want you to come up with the equation of that line. So you need, what's the number one thing you need for finding the equation of a line? Slope. So go ahead, take a minute, find what your slope would be here. When we get to that slope, we will talk about what it means to us. Up on my desk, there's another handout. Okay, so we're getting 2 for our slope. We agree with that? 220 minus 180, and then 50 minus 30. Gives you 40 over 20 and then 2 over 1, okay? Now, obviously, when it's 2 over 1, we obviously write that as 2, right? But I like to write it as 2 over 1 for the purpose of determining what does the slope really mean. Well, if I want to answer what the slope means, and this is in a course type thing, they might have like 4 options, 4 bubbles, and you got to click on what the slope means, okay? That 2 was developed through subtracting 220 and 180, right? The 2 was first 40, the 40 was first 220 minus 180, which was this, right? Which was our Y values, right? So does it make sense that that 2 is a dollar amount or a cost? In the denominator, that came from this 50 minus 30, that was people, right? So right now we've got a dollar amount per one person, right? So when I compare the units of the numerator, it tells me you have $2 for every one person. Does that make sense? So that's how I interpret the slope here. $2 for every one person on board. Okay? So that's nice. Now, we want to go with y minus y1 equals m times x minus x1, right? What do you want to choose for y1 and x1?
30 and 180.
30 and 180. Good choice. Okay? Will the other one work? 50, 220?
Yeah, but too many, too much thing.
Okay. So we go y minus 180 is equal to 2 x minus 30, right? So now I'll get y minus 180 is equal to 2x minus 60, right? All I did there was I distributed, correct? Now how do I solve for y? Add 180, so I get y equals 2x plus 120, right?
No, that's how it is.
Well, remember, we want 1y, right? And we already got that? So we're done. But now we got to kind of interpret what's going on here. Remember, they said how much is the base rate, okay? And a lot of things in real life have base rates. Like if you call a plumber, they're going to have a base rate, and then they're going to have an hourly rate on top of that. Does that make sense? So they come out to your house and say, just to make the visit to your house, maybe we charge you $100. And then you're going to pay us $25 an hour for every hour that we're here on top of that. Does this make sense? Okay. A lot of them will say, we'll come out base rate $100 for the first hour. And then every hour after that, maybe it's another $25 or something like that. Okay. Mechanics do the same thing. Okay. These types of things happen. Okay. Where, because think about a ferry, just like practical purposes here, a ferry is going to have a certain amount of capacity, right? You can't put so much weight on it or it's going to sink, correct? It's going to consume gas. The more weight that's on it, the more gas that needs to be consumed to get the ferry where it needs to go. So they're not going to say, well, we're only going to charge the people weights to go on this ferry. We're going to actually charge the weight of the bus or the cars or whatever, okay? So they determine here with this situation that if you have x to be 0, remember x was your number of people, right? What happens to 2x when x is 0? It goes to 0, right? So you have 0 plus 120. Well, that's 120, right? Y was your cost, correct? So it's saying your cost is 120 when you have 0 people on there. Does that make sense? And that's your base rate. That's the amount that it costs, okay, just to have the bus on the ferry. And for every person that gets on that bus, you're paying a $2 addition to that, okay, per person. That kind of makes sense? I think what gets overlooked a lot of times in an Algebra 1 class, just generally in high school math, okay, and I see this all the time with my seniors, is we learn how to do the processes, but we don't learn what those numbers represent in the process. So I want to make sure that we do spend some time talking about that stuff, analyzing those things. And there's a lot of consistency from this question to the other 3 or 4 that we did last week. Okay. Keep that. I know there's like 30 questions on the handout. We didn't do more than 4 or 5 of them. Keep that. Don't lose it. We might come back to it, just depending on the time that we have in the next couple days. But I do want to move on to section 5.5, which is it's not mind-boggling. Okay. What I think the hardest part about 5.5 is just the understanding that it's something that we've already done. It's just a different format. Okay. Ollie, do you have any nicknames?
No.
No? No nicknames?
I do. Dream killer.
Huh?
Dream killer.
Okay.
And
Weird.
Bonnie, but
All right. So,
no.
let's say
Get up.
no. Let's say that we've got Annika, okay, who goes by Ani,
Yeah, I do.
who goes by Annika,
No.
who goes by Miss Beachy, okay. We've got several different ways of talking about the same person, right? Okay. Well, when we talk about y equals mx plus b, y minus y1 equals m times x minus x1, or when we talk about what we talk about today, ax plus by equals c, these are all different formats of talking about the same exact thing. Does it make sense? This is another format to talk about the equation of a line. Okay. It's called standard form. It's kind of like the most basic form. It's the most accepted form. You know, if something is standard, it's what everybody abides by, right? Okay. So we have standards we have to meet and that kind of thing. and a lot of the activities that we partake in, when they call this standard form, it's kind of like the basic. Okay, I go buy a car and say I want a standard car, standard model or whatever. It's nothing flashy, no.
Your standard.
Yeah, it's just boring, right?
Yeah.
Okay, all right, thanks. Yes.
I have a random.
Yeah.
Can you go from integrated algebra to geometry?
Well, they're like take one, like integrated geometry, like 1 year, and then go to geometry the next year. You will run out because the credits, the way the credits are aligned, is that integrated geometry credit is equivalent to a geometry credit. So you wouldn't be able to earn another credit. Does that make sense? Now you can say I'm working in integrated geometry and it's making a lot of sense to me, maybe the first week, first 2 weeks, 3 weeks. I can go ask to be moved into geometry, but you wouldn't take integrated 2, or I guess it ends up being makes integrated 2. You wouldn't take integrated 2 1 year and then take geometry the next year. Does that make sense? Because they're the same content, so you're only going to get 1 credit for
Why are you
2
whispering?
courses.
Don't make them scream.
All right.
I need to know.
If you want to talk more about that, we can when we're done here. But okay, so it's a key term to talk about standard form. Okay, what this section is mainly going to target is what we call x-intercepts and y-intercepts. You already know what y-intercepts are. What are y-intercepts?
They're on the Y.
Okay, so it's where we cross the y-axis, right? It's where our line crosses the y-axis. So what do you think the x-intercept is? Okay, so where we cross the x-axis. So whenever you cross the y-axis, your x value is 0, right? We're calling that 0, comma b. Okay. So wherever you cross the x-axis as an x-intercept, it's going to be some value a, comma 0. Now I just use b because we've been more familiar with b with the y equals mx plus b format. But a and b in those 2 ordered pairs are any numbers. Okay, they can be anything. Okay, but for an x-intercept, the y has to be 0. Okay, for a y-intercept, the x has to be 0. That's something that we want to kind of commit to memory. Okay, the next thing says, basically right here is kind of the argument that of what I said is that we already know how to do what we're going to do today, but we know how to do it in y equals mx plus b form, and we know how to do it in y minus y1 equals m times x minus x1 form. Okay. Today we're talking about it as ax plus by equals c, which is called standard form. Okay. A couple requirements here for standard form. First off, a, b, and c are going to be real numbers. Okay. A and b are not both 0. If they're both 0, we get 0 equals some other number, and that doesn't make any sense. Okay. So we have to have a and b both being or both existing, one or both existing as coefficients. Okay. Now, when we do this, and I didn't write this, you want to write this down there. A and b have to be integers. A and b have to be integers, meaning they cannot be fractions, they cannot be decimals. Okay? That's part of being that standard form, is that everybody's agreeing upon the format of how we're going to write these. They've agreed, the math community, hundreds of thousands of individuals and hundreds of years ago said A and B have to be positive numbers, A and B have to be integers. Okay? Some textbooks will say that A has to be positive. I don't really care about that. I don't think our textbook abides by that, but some do. Okay. Some textbooks put C on the left-hand side, so it's like AX plus BY plus C equals 0 as standard form. Okay. Ours put C on the right-hand side. It doesn't matter. They all mean the same thing, but it's just different formats of what we consider standard form. But this is what our textbook calls standard form. It's what the end of course exam refers to as standard form. Is that all right? Every equation we come across, every y equals mx plus b equation can be written that way. Everything that's written that way can be transformed into y equals mx plus b. Okay? So we can move back and forth between the different formats. It just makes sense to be able to understand the format that they give me, how to read it, interpret it, and how to graph it. Okay? What I mean by that is, let's say that I take, let's say we got an equation here in standard form of, let's just say 2x plus 3y equals, let's go 18. Okay? If I look at that, that's in standard form, right? The x's and y's are on the same side. The constant of 18 is on the right-hand side of the equation by itself. That is standard form. If I wanted to graph that right now, the only way you know how to graph that is to maybe solve for y, right? Okay, we've done a little bit of this in the earlier sections of chapter 5. Could you make more noise? Can we take this, okay, and rewrite this as 3y equals negative 2x plus 18? Does that make sense to everybody? I'm trying to isolate my y term. And then can I divide everything by 3? So you get y equals negative 2/3 x plus 6, right? Does that make sense to everybody? So right now what I want you to see here is that this format here, standard form, can be restructured through using order of operations and that kind of thing, inverse operations to move things across equal signs to isolate my y variable. Those two green statements produce the exact same line, right? If I look at the one on the right, we now know that our y-intercept is what? If I look at this one right here, my y-intercept is 6, and that's 1 point, right? From there, then I'm going to go where? To graph another point. Down 2, and then right 3. Okay, so then that'll give me another point to plot, right? And I can graph that line, right? Okay. Now, what happens is that was more work than what's necessary. More work than what's necessary. Okay. If my end result is just to graph this thing here that we started with. Okay. Another way that you know how to graph is that you could take, let's say, the x and y. You remember setting up tables? And if I said, okay, well, if x is, let's say x is 2. That number would become 4, right? So I would have 4 plus 3y equals 18. I could subtract away 4 and get this, so y would be 14/3, right? Now that's going to be an ugly point to plot, but we could plot that. And then I'm going to need another point, right? So let's say x is maybe 3. Plug 3 in there, I get 6. Subtract 6 from both sides, this would be 12. Divide both sides by 3 would give me then 4, right? You guys remember doing that kind of stuff, solving for x's and y's when we choose what x was. Okay, that's awesome. Okay, but when we do that, there's a lot of math involved in trying to get that y solved for. Okay, but it's an option. Maybe more time consuming than what's necessary. What I want us to see here is that when something is in standard form, it is so much easier to use our x and y intercepts to solve for 2 points so that we can graph this thing. Okay? And this is what's kind of happening down here. It says this form allows mainly for the locating of x and y intercepts very efficiently. Okay? It says x-intercepts have a y value that is 0. Every x-intercept, no matter where it's at on the x-axis, the y value that goes with that ordered pair is 0. Same thing happens for y-intercepts, but now for a y-intercept, every x value is 0. Okay? It says these properties allow for one to locate intercepts through substitution when an equation is in standard form. So, instead of doing all the routes that are available to us that are maybe more time-consuming, we can now do this. If I have my equation 2x plus 3y equals 18, and I understand x and y intercepts, every line that is non-vertical or non-horizontal is going to have an x-intercept and it's going to have a y-intercept. Does that make sense? Okay. So, for instance, a vertical line or a horizontal line. So those green lines have only one of the two, right? Okay. Every other line is going to have one x-intercept and one y-intercept. Okay. So we're talking about all lines that are not those two. Okay. So if I look at something like that, that's going to have an x-intercept there and a y-intercept there. Does that make sense? If I look at maybe something like that, there's your x-intercept, there's your y-intercept, okay? Every line that is non-vertical or non-horizontal is going to have one of each. That being said then, if I've got an equation in standard form where a and b, the coefficients for x and y, are both non-zero, I'm going to have one x-intercept, I'm going to have one y-intercept. So here's how we do this. You're going to let x be 0 and try to figure out what is the y value that goes with it. Then you're going to let y be 0 and solve to see what is the x that goes with it. This here would be your y-intercept because the x value is 0, right? This here would be your your x-intercept because your y value is 0. Now we're going to use substitution. So here's the nice thing about substitution. If x is 0, what does this expression right here become? What does this term become if x is 0? 0. So it just goes away, right? Is that really easy to solve for y now? What would y be?
0.
No, not in this equation now.
Okay.
What is y right there? How do I solve for y?
Divide by 3.
Divide by 3 and it gives me 6. Okay, is that one point that we could graph? You guys find 0, 6 on a graph? That make sense? Okay, now, so that's 1 point. Now come down here. Now it's saying y is 0. So I'm going to put 0 in right there. What's 3 times 0? 0, so that just goes away, right? And you're left with now 2x equals 18. So if 2x equals 18, what's x? 9. Could I then come over to my graph and go 1, 2, 3, 4, 5, 6, 0, 6. There's 1 point right there. And then go 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9, 0. Is that 2 points on my graph that I can connect with the line? And I graph my line. But would you agree that that inserting of x being 0 and it allows 2x to disappear, and I'm all left with is y, is really easy to find two ordered pairs? That's much quicker than choosing like x to be 2 or x to be 4 or x to be 12. Not really having any plan on what x is. Okay, it's a lot easier than transitioning to y equals mx plus b form. Okay, so let's just real quick, let's look at this line. If I have 2x plus 3y equals 18, okay, if we look at this stuff, is that point right there 0, 6? Is that point 9, 0? Okay, and that's exactly the equation that we started with. Now, like I said, we could do this. We could go y equals negative 3 halves x plus 6. Oh, sorry, it's negative 2/3. Negative 2/3. We could write it that way. Okay, let me color it so you can see the difference here. Okay, when I toggle that back and forth, are those two equations the same line? Okay, but different formats, right? Okay. This one here, when it's provided in standard form, the way to graph it is to find the x and y intercepts. That's the most efficient thing to do. Okay. So let's go to this one here. So just got a couple examples here that are going to work through this process. We have 3x plus 4y equals 24. 3x plus 4y equals 24, and we want to graph that. Okay. So if I want to find my intercepts, okay, so first thing I realize is that this is standard form. A and B are both non-zero numbers. X and Y are on the same side as one another, and this is the C term, or the constant, in that format. Does that make sense? Okay, so that is of the form. Just so we can see another example, another comparison. That's AX plus BY equals some constant. Is that okay with everybody? Okay, so in trying to solve for our intercepts, we're going to have that ordered pair and that ordered pair. So this one says X is 0, right? If X is 0, can I cover that up? And that's basically all I do. When I'm working on this stuff on my computer or my paper in front of me, I just put my hand over that, okay? When I put my hand over it, it essentially goes away, right? And all I'm left with now is 4y equals 24. That's all that's present. So what's y got to be there? 6. Okay. The next thing I want to do is say, okay, now if y is 0. Well, if y is 0, 4 times 0 goes away, right? And now you're left with x to be 8 when you divide. Okay, so let's just see some relationships here. If I plot 0, 6, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Let's connect those with a line. Solid line. Okay. So that is the equation 3x plus 4y. 3x plus 4y equals 24, right? Okay, everybody? Now let me ask you this real quick, because I think these are links, these are connections that we should be able to do. Look at just this graph of this blue line. What is that right there? That's your y-intercept, right? And that's b to b6, right? And that's what we found right there. That was our y-intercept right there. But now if I go from that point right there to that point right there, how many do I have to go down? Down 6. And how many do I have to go over? 8. Okay? So down 6 over 8, that's my slope, right? M would be down 6 over 8, which that reduces to negative 3/4, right? Can I rewrite this equation, just based off of my graph, as y equals the slope times x plus my y-intercept? Does that make sense? Okay. That's one way of coming up with this equation in slope-intercept form. Is graph it using x and y-intercepts, and then just pull up the slope and the y-intercept. Or, can I take 3x plus 4y equals 24 and try to get this thing by itself? Wrong color. Let's get this 4y by itself. How do I get 4y by itself? Careful. If I'm going to try to isolate that green thing, I want to get this to the other side, right? I'm going to subtract that first. Does that give you 4y equals negative 3x plus 24? Does that make sense? Now, how are you going to turn that 4y into a 1y? Now you're going to divide by 4, right? So that gives me negative 3/4 x. 24 divided by 4. Is that 6? Is it the same equation? Okay, so there's a lot of different ways that we can look at the same thing, right? Okay. A lot of different ways, either graphically or a lot of times when we look at the 3x plus 4y equals 24, the algebra part, we call that analytical. Okay. So we either look at the graphical approach or the analytical approach, and we see that we get the same equations regardless of the format that we use. Is that all right with everybody? All right, we'll do this next. This one's kind of nasty. Just because when you do this, so a lot of times the way that they structure their homework questions or test questions or even probably the end of course exam, the ordered pairs turn out to be like integers when we're done, the x and y intercepts. But this one here, let's just set up our ordered pairs. So we're going to have a 0, comma, something, and a something, comma, 0. Okay? If I let x be 0, you're left with this here, correct? Negative 7y equals 30. So then how do I solve for y? Careful. I'm solving for y. Divide by negative 7. So that turns into 30 over negative 7. That's not a really nice number, right? Just leave it as 37ths or negative 37ths because they're relatively prime. They don't share any common factors. Okay, that would be a pain in the butt to graph. But even if I was putting this thing in a y equals mx plus b form, it's still going to be a pain in the butt to graph. Okay, so it's going to still be at negative 37ths as my b value. Okay, so now the next one, the y is going to be 0, right? So when this y value becomes 0, I get 7 times 0 is 0, so it just disappears. What are you left with for? Okay, so x is then going to be 6. So in your homework tonight, they're going to give you an equation in standard form. They're going to ask you find the x-intercept, find the y-intercept, graph it. That's all you've got to do.
Graph it.
Okay. Other questions might be something like example 5. I'll jump down to example 5, and we'll come back to those other two if we get some time here. Here they give you something in slope-intercept form, right? And they want you to get the standard form. So if I want to go to standard form, remember, standard form is ax plus by equals c, right? So that means I need the x's and the y's on the same side. Right now they're separated, right? How do I get that thing to the same side as y? Whenever you're moving things across equal signs, you have two options. You either add it or you subtract it. So I'm going to add it. So I'm going to go y, and it'll be plus 3/7 x equals then 5, right? Okay with everybody? So now we got ax plus by equals c, but remember what I said is that these a values and b values cannot be fractions. They have to be integers.
Minus y.
No, if I minus y, it's going to separate these things. I want the numbers out in front to be whole numbers, integers. What do I need to multiply everything by so this fraction of 3/7 goes away?
0.
If I multiply by 3/7, it's going to be 9, or it's going to be 3/7 here on this y then. It would go away here, give me 9/7 here. But give me a fraction here as well. If I multiply everything by 7, what's 7 times 1? 7. What's 7 times 3? 21. What's 1 times 7? What's 21 over 7? 3. So those 7s cancel and leave me essentially with that 3x, right? And then 7 times 5 is 35. So that's my equation in standard form. Okay? I don't think Math Excel is going to do this to you, but some textbooks will say your x has to show up first. So if I wrote 7y plus 3x equals 35 and it marks it wrong, but I know I did everything right, it's because they want your x to come first. They want it to be written as 3x plus 7y equals 35. Your textbook, as I read through the actual textbook, it doesn't discuss that necessity from this author. So I don't think Math Excel is going to throw that wrench in there at you. Does it make sense? But if at any time you do know you're doing everything right, you got the right equation, but it's marking it wrong, or if you read the feedback and it says something about like talking about the correct standard form or whatever, jockey your x's and y's around and see if that fixes the problem. So what happens here, if we need to get rid of fractions, you multiply by what we call the LCD, the least common denominator. So if I had something like this, let's say that we had, like, let's just say 1/2 x plus 2/3 y equals 4. So let's say whatever our equation we started with, we try to get the standard form, we do this. So x's and y's on the same side, right? So it's in standard form except for the A and the B need to become integers. Okay? What could I multiply everything by so that this 1/2 goes away? Say it again. So I want it to go away. If I multiply by 2, 1/2 times 2 makes the 1/2 go away and I become a whole number, right? But if I multiply everything by 2, 2 times 2/3 is 4/3, right? So it's still a fraction. I still have a fraction somewhere in this equation. What would I multiply 2/3 by?
2/3.
Well, if I multiply 2/3 by 2/3, I get 4/9. And 4/9 doesn't go, it's still a fraction, right? What'd you say I multiply by? 3. If I take 2/3 times 3, I get 6/3, right? What's 6/3 the same as? 2. So we need to multiply everything by 2 and then multiply everything by 3. Well, what's that the same as multiplying by? 6. Okay? So when I say LCD, what we're going to do is we're going to go through and look for all your denominators. In this case, 2 and 3, right? And we'll pick those off and multiply them together, and then that's what I need to multiply the entire equation by. So when I multiply 1/2 by 6, what's half of 6? 3. So multiply everything by 6 here. So half of 6 is 3, so I get 3x. Okay, now I multiply 6 by 2/3. What's 6 times 2? 12. So I got 12 on top, right? Now that 6 has a denominator of 1, right? What's 1 times 3? 3. So I got 12/3, which is same thing as 4. Good. So I get 3x plus 4y. And now I need to multiply everything by 6. So I even need to multiply 4 by 6. So it gives me 24. The quickest, easiest way, guys, to check these, to see if you've got the right format, is go to Desmos. Now, Desmos is a really nice graphing calculator because we could type in 1/2 x plus 2/3 y and set that equal to 4, and it gives me that line, right? If I type in 2x, sorry, what was it? Was it 3x? Yeah, 3x plus 4y. 3x plus 4y equals 24. Does it give me the same exact line? Does that make sense? Okay. 2 different versions of the same thing. Is that something we can do? What about let's do this one. Let's just solve for the ordered pairs here. For the x and y intercepts. So if x is 0, figure out what y is. When y is 0, figure out what x is. So if x is 0, that goes away, right? So what would y be? Divide by -2, right? -2 divided by -2. If y was 0, and this is why I wanted to do this one, what does that say x is? It says x is x. Remember, equal sign is the word is, -2. So x is -2. Plot them 2 points. That's it. 0, 1, and then down. So -2, 0 would be left 2, up 0, right? So if I look at those 2 points just real quick, let's say that I asked you from this image, from this information, to solve and tell me what your slope is. What your slope between those 2 points?
1/2.
Yep, up 1/2. So can I go up 1/2, get another point?
Yes.
I can do that as many times as I need to get enough points to graph that thing. Is this something we can do? Okay. So my hope is that, think about this. It's something a little bit new, but it's just substituting, right? Which we learned how to do in chapter 2. This is what I'm just telling you now. This is what you have to substitute for x. This is what you have to substitute for y, and then evaluate and put that together in your graph. Okay. So the hope is that we understand that all the algebra that we do from here on out, we have learned the basics already. Chapter 1, Chapter 2, in 8th grade, learned all those basics. Now we're just going to kind of combine them and see how they generate new ideas, new concepts. Okay? Like I said, 5.5 is available. Take a look at that before tomorrow evening. If you have any questions, we can answer those tomorrow in class.